Hello everyone, this is Miss King with our next installment on thermochemistry. Today we'll be taking on the topic of heat capacity and specific heat. So we're going to start with some definitions. First off, we got heat capacity. Heat capacity is the amount of heat needed to increase the temperature of a whole object by exactly 1 degree Celsius. Heat capacity depends on both an object's mass and its chemical composition, so what's it made out of and how big is it. So an example of this could be that it requires more heat to raise the temperature of a cup of water 1 degree Celsius than a drop of water. So the cup has a higher heat capacity. In this example, they are the same substance, same chemical composition, but the cup of water has such greater mass that it has much higher heat capacity. It can take and absorb much more heat without its temperature increasing as much. And then we also have this idea of specific heat. We're going to see this concept quite a lot. And specific heat is the amount of heat it takes to raise the temperature of 1 gram of the substance by 1 degree Celsius. Take note of the units here. It's energy units divided by grams degree Celsius. So either joules per grams degree Celsius or calories per grams degree Celsius. As you may be anticipating, different substances have different specific heats. So let's take a look at that. Here's a table that we're going to see quite often. It has different materials along with their specific heats. Important thing to note here, the highest value you'll see on this table is the specific heat for liquid water. It takes a lot of energy to heat up liquid water. This is another cool diagram. I like this one. It has 1 calorie down here. Remember, a calorie is defined as the amount of energy that it takes to raise the temperature of 1 gram of water, 1 degree Celsius. So we got water down here at 1. That's how much it'll heat up if you give it 1 calorie. Gasoline, it'll also heat up only a little bit. And you got a bunch of other materials here. I think it's kind of cool to see gold up here. So one of the reasons people like gold, and it's really nice for jewelry, is because it stays really warm. And that's because it has a really low specific heat. It warms up without a ton of energy. One more cool quality of specific heat of water that I want to mention before we move on is because it has this really high specific heat, it can absorb lots of energy. And this is actually the basis of weather and storms. So weather made out of water, which has been evaporated, is able to transport really large amounts of energy from one part of a globe to another. And this is the basis for why storms happen where they do and how they move. So very interesting, very cool. Last thing we'll talk about is how do you calculate specific heat? For our calculations, we're going to be using the following equation where, there's my cursor, Q equals M times C times delta T. Q, we've seen this before. That's the amount of heat energy either gained or lost, usually in joules, maybe in calories. M is going to be the mass of the substance in grams. C is heat capacity, so in some instances you'll look that up in a table like we were looking at a second ago. And then delta T is change in temperature, which can also be written as final temperature minus initial temperature. Now let's look at an example problem. So in this problem we have that we're adding 435 joules of heat to 3.4 grams of olive oil at 21 degrees Celsius. The temperature increases to 85 degrees Celsius. What's the specific heat of the olive oil? So from this problem, we'll pull out our information. So we have 435 joules of heat. That's going to be our Q value. We have 3.4 grams of olive oil. That's going to be our mass. We have an initial temperature and we have a final temperature. We can use that to calculate our delta T, which is that 85 degrees Celsius minus 21 degrees Celsius equals 64 degrees Celsius. From there, we're just going to plug into that equation and solve for C, the specific heat. We do that. Solve for C. And we get a final answer of C equals 2.0 joules per grams degrees Celsius. And that is heat capacity and specific heat in a nutshell. I hope that helped, and now it's time for y'all to get some practice on your own.